Hello ladies and gentlemen, this is Mr. Simmons again with the Pythagorean Theorem. This is part 4 where we start solving real-world problems. Now I'm not going to solve all of these problems, I'm just going to show you how you can use the steps to find your answers. I'm going to break the problems down for you, but you're more than welcome to pause the video at any time and go ahead and solve each problem and then practice using the Pythagorean Theorem. Okay, so here we go. In this problem, we have the baseball player throws a ball from second base to home. How far does the player throw the ball? I'm going to tell you in a lot of these with the diagrams, you need to go ahead and draw and label everything. If it has a picture, use it to your advantage. So I'm going to draw a line from second base to home because that's the distance it's asking me to solve for. I also want to point out that this makes a right triangle, and that's the key idea in knowing what to do is if you see a right triangle and you're trying to find one of the distances, then it's the Pythagorean theorem that's going to help you to find your answer. So you also notice that I've created a right angle here, and a right triangle I should say, and so I can find this missing hypotenuse because the legs are the 90 feet measurements. So once again, you just have to identify the right triangle. Okay, so let's go on to the next problem. Here it talks about a firefighting ladder being 110 feet long. So there's my ladder, the blue, and it's 110 feet. It also tells me that it is 28 feet from the building. So I draw a line over to the 28 feet, which also shows you that it's 8 foot off the ground is where the base of the ladder is. So I continue drawing, and I draw from the top of the ladder down to the 28 feet edge here, and you notice that it makes a right triangle inside. There's my right angle, and across from the right angle always points at side C. So I've already started the labeling process of identifying sides A, B, and C. Then I would just need to write out the Pythagorean theorem, substitute the values, and solve using those 4 steps. Now here I have 3 different problems, and each one of them is a right triangle. So once I identify the right triangle, I can solve. All of these problems are trying to find the height of something here. Value x is a height. So Pythagorean theorem is used quite often to find the height of something. Okay, and once again, once you find your right triangle, label A, B, and C, the 3 sides, write out your Pythagorean theorem, substitute in the values, and simplify or solve. Here's another example of a real-world problem of cutting across. And so a lot of times we know north and south distances or east and west distances, but we don't know the diagonal. Well, that creates a right triangle, as you can see in the diagram. Here's my right triangle. And so I can use my Pythagorean theorem and solve for this one as well, using the 4 steps I've given you. Now here's another problem. This gets into carpentry or building houses, and so you want to know how far are you going from point A to point B. Well, if you've measured your steps and you've created 8-inch by 10-inch steps, then you can put this together to make a right triangle. Right here is the right angle, and now you can identify your sides and write out your Pythagorean theorem, substitute your values, and then solve for the thing that you're missing, which is the hypotenuse distance from A to B. Okay, so projects, a lot of times we get boxes or any kind of a box, and you see that it has rectangular edges. Well, every diagonal across a rectangular edge creates a right triangle. So if I draw on the face here, this face rectangle, if I draw a diagonal, well, that makes a right triangle. So no matter which way I do that, I'm going to get a right triangle. Do you see the right triangles here? And so it creates 2 right triangles. So no matter which way you go, you can find the diagonals. Even when you look going inside from one corner to the opposite corner, making a diagonal, you can find that measurement as well using the Pythagorean theorem. And the coordinate plane, quite often you have a distance formula which uses the Pythagorean theorem. And that is used to measure the distance between 2 points. Well, when I do this, it automatically creates right triangles for me. If I draw my horizontal line on the point and I continue over when I get to the height of the other point, I continue over, you can see it makes a right triangle. And it doesn't matter which way I go. If I go from one point to the other, it doesn't matter which way I do this, I'm still going to make a right triangle. So even if I box it in, it creates 2 right triangles, and I can choose which one I want to use to solve. This is quite often used in algebra. Okay, so next problem. Okay, so here is how one is used in the real life in maps. So if you're at home and the park is 5 miles east of your home, so you go 5 miles to the east, see this is east, to the park. And the library is 4 miles north of the park, so I go directly north and I get to the library from the park. And now you're wondering, well, how far am I from my house? So you're at the library here. How far is this measurement back home as the crow flies? Well, you can find this distance using the Pythagorean theorem. So the first thing you need to do is identify your right triangle. And there's the right angle. So now you label your sides. So I point across from it to find side C, which is already given. I label side A and side B, and then I write out my steps, I write out my Pythagorean theorem. A squared plus B squared equals C squared. Now I substitute in the values, 4 and 5 for A and B. And then I begin to simplify and solve. So I get 16 plus 25, which is 41. I take the positive square root of each side, and I'm given approximately 6.4 miles is the distance from the library to my home, cutting across country. As we look at this next problem, it is also on the coordinate grid. The problem reads, determine the perimeter of the following figure to the nearest hundredth of a unit. Well, the figure is a trapezoid. And as we look at it, we're like, okay, well, I know that perimeter means that I got to add up all the sides. Well, I know that this side here is 1, 2, 3 units, so I'm going to label it 3 units. I know that the bottom edge is 1, 2, 3, 4, 5, 6, 7 units, so I'm going to label it 7 units. But these are diagonals, and I can't really get an exact measurement on them. And it tells me I'm going to have to approximate to the nearest hundredth anyway. So with that said, I know that I need to create the right triangles. So I can create 2 right triangles, one on this side, one on the other side, to find those diagonals. Now, if you look at it, you should realize that both of these have the same measurements. So this side is 2 units, and this side is also 2 units. It creates my right angle here to make the right triangle, which points at side C. So I'm missing 2 side C's. Well, knowing that it's perimeter, let's create a formula for that. So perimeter equals my sides added up. Well, I know 3 plus 7, so 3 plus 7 plus side C plus side C, since they are the same because they have the same measurements. Okay, so I can then solve. 3 plus 7 is 10, and now I just need to find out how many C's this is. Well, this is 2 C's, so I'm going to be adding in 2 C's. Now I got to find out how long is this and plug it into this formula. With that said, let's start labeling everything. So knowing that this is a right triangle, I know side C is here. I need to identify sides B and C. So I could call this first one A and the second one B, and then write out my Pythagorean theorem. A squared plus B squared equals C squared. So A in this case is 2, so 2 gets squared. B is also 2, so 2 is squared again, equals c squared. 2 squared is 4, plus 2 squared again is 4, equals c squared. I get 8 equals c squared. Once again, I take the positive square root of both sides. And now in my calculator, I type in the square root of 8, and I get 2.828. Oops. You notice that this says to the nearest hundredth of a unit. Well, the hundredth position is 2 spaces after the decimal. So here's the 10th, and the hundredth is right here. So this 8 rounds the 2 either up or down. And because it's an 8, it rounds it up. So this is approximately equal to C, which is actually 2.83 as I round that up. So I can now substitute in C is approximately 2.83. So I can finish my formula. So P equals 10 plus 2 times 2.83. I type that in my calculator, or I can type in 7 plus 7 plus 2.83 plus 2.83, and I'm going to get 15.66 units. Well, as you notice, that is D. Okay? I hope this helps you to solve a different style of figure using perimeter. Let's look at our last problem. Okay, a support wire 16 yards long is attached to the top of a utility pole 12 yards tall and is then stretched tight to the nearest tenth of a yard. So we're going nearest tenth of a yard. How far from the base of the pole the wire will be attached? So we need this measurement from the base of the pole to where the wire is attached. How far is that distance? Well, this creates a right angle here, making a right triangle. So I label the sides. I always do side C first. So there's side C. I can label this one A, and B is missing. I write out my Pythagorean theorem. A squared plus B squared equals C squared, where A is 12, B is unknown, and C is 16. 12 squared makes 144. Still have B squared here. 16 squared is, well, let me see, 16 squared, 256. And now I subtract 144 from both sides because I got to isolate B. So I got to get rid of the 144 so that way B will be by itself. I have to subtract that from both sides. These cancel. Leaves me with B squared. 256 minus 144 is 112. So I take the positive square root of B squared and 112. Positive square root of B squared is B. And the square root of 112 is approximately, notice that we're going to the 10th, so I need to go past the 10th position. So it says 10.5. 5 is the 10th position, so I need to go one more number. So I can use this number to round the 10th position either up or down. With that said, the 8 rounds the 5 up, so I know that B is going to be approximately equal to 10.6 yards. And I can box in my answer. I hope this helps you solving real-world problems. Remember, always identify the right triangle in the problem and then use the 4 steps that I've given you in solving each one. Thank you for watching.